Hi all, this is the second session in the first module, Introduction of Data Science. It covers the contents, big data and data science hype, the data science process, the big data and data science hype. There may be several questions regarding what is that big data anyway, and what does data science mean? And what is the relationship between big data and data science, etc. So when we look forward about the big data, what is big data? Big data is a collection of data that is huge in volume yet growing exponentially with time. It is a data with so large size and complexity that none of traditional data management tools can store it or process it efficiently. Big data is also a data but with huge size. Big data is essentially a special application of data science in which the datasets are enormous and require overcoming logistical challenges to deal with them. The primary concern is efficiently capturing, storing, extracting, processing, and analyzing information from these enormous datasets. Processing and analysis of these huge datasets is often not feasible or achievable due to physical and/or computational constraints. Special techniques and tools, for example, software, algorithms, parallel programming, etc., are therefore required for this. The big data is the term that is used to encompass these large datasets, specialized techniques, and customized tools, and it is often applied to large datasets in order to perform general data analysis and find trends or to create predictive models. You may be wondering why the term big data. We have collected a lot of data of various types on a large variety of data storage mechanisms for a long time, right? Yes, we have, but we have never before enjoyed such inexpensive data collection, storage capabilities, and computational power as we do today. So, where exactly does this data come from? The large amounts of data are gathered from mobile devices, remote sensing, geolocation, software applications, multimedia devices, radio frequency identification radars, wireless sensor networks, and so on. When we look into big data, these are some examples based on the big data. The first one, or the main one, is the New York Stock Exchange generates about 1 terabyte of new trade data per day. And the next is the statistic shows that 500 plus terabytes of new data get ingested into the databases of social media site, Facebook, every day. And this data is mainly generated in terms of photo and video uploads, message exchanges, putting comments, etc. And also, another example, a single jet engine can generate 10 plus terabytes of data in 30 minutes of flight time. With many thousand flights per day, generation of data reaches up to many petabytes. And types of big data. Following are the types of big data. It includes structured, unstructured, and also the semi-structured forms. So when we look these three briefly, when we look into the structured form, any data that can be stored, accessed, and processed in the form of fixed format is termed as structured data. Over the period of time, talent in computer science has achieved greater success in developing techniques for working with such kind of data, where the format is well known in advance and also deriving value out of it. However, nowadays we are foreseeing issues when the size of such data grows to a huge extent. Typical sizes are being in the range of multiple zettabytes. And according to the information, 10 raised to 21 bytes equal to 1 zettabyte or 1 billion terabytes forms a zettabyte. And for an example of structured data, here shows an employee table in a database, and this is an example of structured data, which is in a structured format, including employee ID, employee name, gender, department, salary in lakhs. Then the next is unstructured format. Any data with unknown form or structure is classified as unstructured data. In addition to the size being huge, unstructured data poses multiple challenges in terms of its processing for deriving value out of it. A typical example of unstructured data is a heterogeneous data source containing a combination of simple text files, images, videos, etc. Nowadays, organizations have wealth of data available with them, but unfortunately don't know how to derive value out of it since this data is in its raw form or unstructured format. For example, of an unstructured data, the output returned by a Google search. It's a type of unstructured data. The next is semi-structured format. The semi-structured data can contain both the forms of data. We can see semi-structured data as a structured in form, but it is actually not defined with a example, a table definition and relational DBMS. For example of semi-structured data is data represented in an XML file. It shows the data and the data growth over the year using the Excel or graphical representation. Then, the characteristics of big data. The big data can be described by the following characteristics. The first one is volume. The name big data itself is related to a size which is enormous. The size of data plays a very crucial role in determining value out of data. Also, whether a particular data can actually be considered as a big data or not, it is dependent upon the volume of data. Hence, volume is one characteristic which needs to be considered while dealing with big data. The next is variety. Variety refers to heterogeneous sources and the nature of data, both structured and unstructured. During earlier days, spreadsheets and databases were the only sources of data considered by most of the applications. Nowadays, data in the form of emails, photos, videos, monitoring devices, PDFs, audio, etc. are also being considered in the analysis applications. And this variety of unstructured data poses certain issues for the storage, mining, and analyzing data. And the third one is velocity. The term velocity, it refers to speed of generation of data. How fast the data is generated and processed to meet the demands determines a real potential in the data. Big data velocity deals with the speed at which data flows in from sources like business processes, application logs, networks, and social media sites, sensors, mobile devices, etc. The flow of data is massive and continuous. Then the fourth one is variability. And this refers to the inconsistency which can be shown by the data at times, thus hampering the process of being able to handle and manage the data effectively. So the top big data applications include healthcare, travel, education, finance, retail, telecom, e-commerce, media, entertainment, etc. Benefits of big data processing. When we look for about the big data processing, what are the benefits based on them? It includes mainly the first one is businesses can utilize outside intelligence while taking decisions. The improved customer service, early identification of risks to the product or services, if any, better operational efficiency. And when we look the data science hype, data science have a lot of star power in the name itself. So they inspire people to dream and imagine a better world which leads to their overuse. More buzz around our industry raises the tide that lifts all boats, right? Sure, we all hope the tide will continue to rise. But we should work for a sustainable rise and avoid a high bubble that will create widespread disillusionment if it bursts. The frequent overuse of artificial intelligence when referring to any solution that makes any kind of prediction that has been a major cause of this hype. Because of the frequent overuse, people instinctively associate data science projects with a near perfect human like autonomous solutions. Or at a minimum, people perceive that data science can easily solve their specific predictive need without any regard to whether their organizational data will support such a model. And this all leads to the data hype. Then the next topic is data science process. Here defines the 7-stage data science process. Problem framing define a clear, concise, concrete problem statement. Data acquisition, it says about to collect the data from open source online repositories or CRM. Data preparation, it process and transform data using exploratory data analysis. Model planning, it shows finalize the training model for data sets, regression and classification. Then the fifth one is model building. That is, it says build the model using training data, evaluate performance using testing data. Then the sixth one is visualization communication. It prepare contrasting visuals for actionable insight and hidden patterns within data. Deployment maintenance shows it's deploy the model to mainline frame. Iteratively retrain the model with new data. So the 7 steps that remain a constant part of the complete data science process, it includes these 7. The problem framing, data acquisition, data preparation, model planning, model building, visualization and communication, deployment and maintenance. When we look each of the steps, the first step is problem framing. You may have a million bytes of data, but if you don't know exactly what to do with this data, you are never going to end up anywhere. In simple words, you need to have a clear, concise, and concrete end goal in mind before you even start working on any of the data science project. And to set an end goal, you must try to get into the head of your client and gather as much information as possible about the problem at hand. Most of the industries use key performance indicators to gauge their performance at a macro level. To leverage this detail, you may want to come up with an insight that affects a major key performance indicators directly. In essence, you must try to frame a business problem and then formulate an initial hypothesis test. The next step is data acquisition. And this is the major step, and it is to collect the data relevant to the problem statement you are targeting. If you want to forecast a general behavior among a large group of population, you may want to explore the open source or paid datasets available from various resources, such as online dataset repositories, web servers, databases, research labs, social institutions, survey repositories, public institutions. On the contrary, if you just want to achieve a specific business goal, you should be focused on acquiring the data from the company's customer relationship management software. Ideally, you should aim to fetch the relevant data from the application program interface of the CRM, such as customer information, sales call, email open rate, follow-up emails response, social media ad engagement and analysis, website traffic analytics, and visitors demographics. Essentially, you should try and collect as much data as possible to help you extract meaningful patterns and actionable insights using a more comprehensive approach. When we look into the step 3, data preparation, once you have acquired the raw data, the first thing you will come across is the need to prepare the data for further processing. After reconditioning the data, you will need to remove all the underlying problems with the data entries themselves. So the first thing you must think about it is identify any data categories which don't add value and remove them from the datasets. For example, if you are selling an item only suitable for the ages of 18 and above, then there is no need for including the data of teens won't do any good. Then the next thing to identify is any potential gaps in the data, because the people with the different demographics, locations, age groups, genders, etc. all must be identified. Then the third one is resolve conflicting values in the datasets. For example, human age cannot be negative. Like that, an email address must contain a symbol. The phone number must include the city or country code. Also, make sure each column of the datasets follows a specified format. For example, time of purchase should either be in 12-hour or 24-hour format. Age should be written in Roman numerals. Phone number should be not contain any dashes, like that. The next thing we must think about is remove the inconsistencies in data. That is, add the missing values, remove the bogus values, smooth out the data noise. And then the last thing we must think about is join the data from multiple sources in a logical manner such that the format remains the same. You may want to combine the sales data from a Facebook store, personal website, and different affiliate websites. Once you have resolved all the anomalies and unusual patterns in the dataset, you need to ensure that the data is formatted in a consistent and homogeneous manner. During all the data transformation and cleaning, you must comply with the data usage license as well as all the legislations concerning the privacy and protection of personal data. Then the fourth step is model planning. At this stage, you have the data formatted and sorted out in a large number of categories or variables. Now it is the time to start exploring and drawing the relationship between these variables. In most cases, you will need to apply exploratory data analytics to finalize a training model for your data. You can use visualization and statistical formulas to use various exploratory data analytics techniques, including bar graphs, line charts, pie charts, histograms, box plots, and trends analysis, etc. Some of the popular tools for model planning include, but not limited to these, The first one is SQL analysis services. And the next is SAS, proprietary tool for a comprehensive statistical analysis. R is a machine learning algorithm, statistical analysis, visualization. Python for data analysis, machine learning algorithms. MATLAB, proprietary tool for statistical analysis, visualization, and data analysis. The next step is a model building. Once you have performed a thorough analysis of data and decided on a suitable model algorithm, it's time to develop the real model and test it. Before building the model, you need to divide the data into training and testing data sets. In normal circumstances, the training data sets constitutes 80% of data, whereas testing data sets consist of remaining 20%. Firstly, training data is employed to build the model, and then testing data is used to evaluate whether the developed model works correctly or not. There are various package libraries in different programming languages, that is R, Python, MATLAB, which you can use to build the model just by inputting the labeled training data. This is a machine learning algorithms for model building. So the unsupervised learning, we use clustering and dimensionality reduction. So when we look forward about the clustering, there are k-means, mean shift, k-medoids. And dimensionality reduction, principal component analysis, feature selection, linear discriminant analysis. When we look into the supervised learning, there are two ways, regression and classification. Regression, decision tree, linear regression, logistic regression, and in classification, Navy Bayes, SVM, k-nearest neighbor. The third is reinforcing learning. Some of the tools which can help you build and test the models are listed as under. The first one is MATLAB. The second is Pika. The third is Alpha Minor. And fourth is SAS Enterprise Minor. The fifth one is SPCS model. And the last one is statistical. Then the next step, the sixth step is visualization and communication. Once you have trained a model and successfully tested it, you still need to break one last barrier known as communication gap. Since a picture is worth 1,000 words, you need to back your communication skills with interesting visuals and graphics. You can make use of the following tools to convey your results more convincingly. Tableau, Microsoft Excel, Google Sheets, MATLAB visualizations and graphs, Canva, anything. The last step is deployment and maintenance. Once you are confident that the model will solve the underlying problem statement well, you should deploy it for real customers and keep on tracking its performance over time. Besides, you need to check back regularly to evaluate if there have been significant changes within the environment in which the model was operating. So the maintenance is a very important thing under data science, because when we look forward to this, if any changes occur without our knowledge, it's a big issue. So these are all the references I referred for these informations. So thank you all. If any questions, please feel free to ask. Thank you.